Hello students, I welcome all of you in this lecture. In this lecture we are going to see the functions, types of functions, the functions that are used in economics and relationship between them, as well as we will try to learn some interesting functions like cost function, revenue function and profit function. So let me start with the basics of the functions. So the very first thing that we should know about the functions is that the terms involved in that particular concept. The very first term that is involved in that concept is a constant. So what do we mean by a constant? So constant is a quantity which do not change. Constant is a quantity which do not change. Okay? Basically, we denote constants by numbers. For example, I can write some examples here for your reference. For example, 2 is a constant, 3 is a constant, 4 is a constant, 5 is a constant, likewise so on. Even I can take 1.2 is also a constant. Then after discussion of this first concept of constant, let me now jump my attention to the next concept of variable. Variable is the opposite of constant. Constant is a quantity which do not change, whereas variable is a quantity which changes. Means you can take the different values for that particular variable. Okay, if I would like to take some example, I can take age. Age is a variable, right? If you go from person to person, age of that person will go on changing, right? Then even weight is also a variable. Then I can tell you that variables are denoted by the symbols of small letters like a, b, c, or sometimes x, y, z. So these are the symbols of variables. Okay, so after discussion of constants and variables, now it's time to discuss some more concepts that are involved in the case of functions. Now let me discuss some of the concepts that are involved in the functions. Basically, what is a function? So function is nothing but a map that assigns for each value of x a unique value of y. Now it will seem something which is not known to you. So let me take one example and accordingly I will try to make it understand to you the particular concept of function. Okay, so let me take an example of a menu card of a canteen. So if we will see menu card, then on the left of the menu card the name of the food item is given, right? And on the right side price of that particular item is given to you, right? So here will be some food items like A, capital B, C, these are the food items, and here will be some prices. Okay, so for example 10 or suppose 5 or suppose 15 or suppose 20. So these are the prices. Okay, so now you can easily understand that for every food item there is some price associated with that particular food item. Okay, so for example price of A is 10, price of B is 5, price of food C is 15, price of food D is 20, right? Okay, so this is the thing, and you can see that every food item has a unique price, right? So you will not find that some food item has given to different prices, right? For example, suppose there is some food item, it is not possible that food item A is for 10 rupees and again you will see that same food item A is for the 15 rupees. So this is not possible in the case of menu cards, right? So for every food item there is unique price. Okay, so what we call in our mathematical definition is that the things that we are taking on the left, okay, for which we are finding the prices, we call this as a domain, right? Because we are taking the value of that particular variable from this side, left side, so we call it as a domain. Then we find the prices on the right side. Okay, so this is called as a codomain, right? And Now you can see here that price of A is 10, price of B is 5, price of C is 15, price of D is 20. So if we find the range, then 10, 5, 15 and 20, these elements will be in the range. Okay, now let me jump from this example to a different example. Okay, suppose if I'm talking about the cricket team of India, right? So you can easily see that name of the player, right? And on the right side we write the role of that player. For example, if I am writing Virat, okay, then what is the role of Virat? So Virat Kohli is batsman, right? And he is captain. If I will take the next player, suppose I am taking Rohit Sharma, he is also batsman, vice captain, but I am not writing that here, right? You can take many more players, right? So I can take suppose for example Hardik Pandya. So this particular player is all-rounder, he can bowl, bat, okay, so he can be batsman, he's bowler also, right? I just want something to tell you. That's, you can see that when I took Virat Kohli on the left, I found two different images for Virat Kohli, that he is batsman also and he is captain also. If I take Hardik Pandya, then I can find two different images for the Hardik Pandya, that's batsman also and bowler also. So this is not possible in the case of functions. Okay, so this kind of map is not a function. So what function means? Function means that for every element that you are taking, okay, there is unique image for that element, then such a map is called as a function. Now let me take some mathematical example and let me show you how to find it. So domain, let me just write down these terms now. Domain, a set on which function is defined is called as domain. Then let's talk about the codomain. Codomain is nothing but a set where we find images, or we locate images of elements of domain. Okay, then range. Range is nothing but the set of all images. Means suppose you took one element by one element and you found out the images, then set of all images, okay, of elements of domain is called as a range. Okay, then let us now define a function. Okay, so I already have told you with the help of examples that for every element, let me write that element as x, there is unique image, there is unique image y. Okay, and we denote function by some f or g. Okay, it is denoted by f. Okay, so what can I write? That if I am taking x, then and if I apply f on that x, then image is y. Okay, so I can say that f when applied on x gives me y. So f of x equal to y, and this is called as a function, right? Now as I told you, let me take some mathematical example. So let me define a function f from a set. I am taking set for example 1 2 3 4 5, right? And I am taking some set here that 1 2 3 4 5 6 7 8. Okay, and I'm defining map like this: f of x is equal to x plus 2. Okay, now you can easily tell me what is f of 1. Okay, so what you have to do, whenever x is given to you, you have to add 2 to that x and you will find the image of that x. So if I put x equal to 1, then I can understand that f of 1 is 3, right? If I put x equal to 2, then I can understand that f of 2 is equal to 4. If I put x equal to 3, I can understand that f of 3 will be 3 plus 2, that is 5, right? Similarly, what is f of 4? I can understand that f of 4 is nothing but 4 plus 2, that is 6, because that is a rule given to me. This is a rule, right? And I have to work with this rule. This is a rule of my function. Okay, and what is f of 5? So finally, if I am talking about f of 5, then f of 5 is nothing but 5 plus 2, 7, right? Now let me just locate the domain, codomain, range of this function. So what is domain? I talked about this. Domain means from where we take the function values, or for values which function is defined, right? So function is defined for these values 1, 2, 3, 4 and 5. So my domain will be 1, 2, 3, 4 and 5, right? Then what is my codomain? So codomain means where we find the images, where we try to find out the images. So I am trying to find out images in this set, right? So this set is my codomain. So my codomain is 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then I will talk about the range. What is range? Range means the set of all images. Now you can see that what is image of 1, 3. So 3 will be there in my range. What is image of 2? 4. So 4 will be there in my range. Then 5 is also image, so it will be in range. 6 is also image, and 7 is also image. So this is my set of all images. You can easily understand that 1, 2 and 8 are not the part of range. Okay, so in this way we find out the domain, codomain and range of a function. So I hope that you must have understood the constants, variable, what is function, what is domain, codomain, range, okay, and how to find out that. After this discussion, now let me move to the some types of functions. So we basically talk about some very fundamental or very standard functions. So the first function that we talk about is the constant function. Constant function means what? Whatever the value of x may be, the image is going to be constant. Okay, for example, f of x is equal to c. This is a rule of that function. F stands for a function, x stands for a variable or element taken from a domain, and c is the image where c is constant. C equal to constant. So this kind of function is called as a constant function. I will take an example and I will try to draw the graph of that particular function. So let me define that f of x equal to 2, right? F of x equal to 2. Now f of x equal to 2, if I am taking, and suppose my domain is a set of all real numbers. Set of all real numbers is my domain. So in short, I am telling you that my function is from real numbers to real numbers, and defined as f of x equal to 2. So that's my rule. So f of x equal to 2, that's my definition. Now if I will try to find out the graph of this function, so how the graph will look like. So this is my x-axis, right? This is my y-axis. So I can take them as domain and codomain, right? So this is y-axis, right? So what this is, suppose 2. Whatever the value of x you are taking, suppose you are taking any value, the image will be 2. So even if your x is equal to 1, image is 2, x is equal to 1.5, image is 2. Whatever the value of x may be, your image is always 2. Okay, so if you try to draw a line from these points of images, you will find the graph of constant function like this. So this is called, such a function is called as a constant function. After constant function, let me discuss the next type of function, that is second function. It is called as a linear function. Linear function itself indicates its meaning that this function is defined as a linear equation, and the graph of this function is a line. Okay, so for example, how the functions are defined. So functions is of this type: f of x is equal to a into x plus b, where a and b are constants. Okay, a and b are constants. So this is f of x equal to ax plus b. So a and b are constants. Such function is called as a linear function. Okay, now let me take some examples. For example, f of x equal to 2x plus 1, or suppose f of x equal to 3x plus 5. Okay, even if I am taking f of x equal to 4x, then it is also a linear function because I have taken b equal to 0. That is accepted, right? So f of x is equal to 4x. This is also a linear function. So this kind of functions are called as a linear function. And what is the graph of such a function? So graph of function is a line. That line may be anyhow, that line may be passing through origin, that line may be making some intercepts with x and y axis. So this kind of graph can be plotted for the linear function. After talking about linear function, let's talk about the third type, that is power function. How the power function is defined? Power functions mean that in that particular case we take a power of x. For example, f of x is equal to x raised to n. Okay, f of x is equal to x raised to n. This is called as a power function. Okay, just a second, let me write that in properly here. So f of x is equal to x raised to n is called as a power function. You can take many more examples. F of x equal to x square, then you can take f of x equal to x cube. Likewise, you can define many more power functions. Okay, now after talking about the power functions, let me come to the next type of functions, which are called as a very interesting and very important type of the functions, that is exponential functions. Now exponential functions are very interesting, and they seem indicate the meaning of that, because exponential function is something with exponent, right? So that means की या फंक्शनमध्ये तुम्हाला जे काही x दिला असेल, ओके, तुम्ही त्याचा काहीतरी घातांक घेणार किंवा x स्वतः घातांकामध्ये असेल, राईट? सो लेट मी जस्ट क्लियर दिस आयडिया. So exponent means x itself act as an exponent. For example, suppose f of x is equal to a raised to x, okay, where a is positive number, so this is called as an exponential function, because in this particular situation x is itself a power of that element, right? So a raised to x, I'm not taking x raised to x square, I'm taking a raised to x, or even I can take where a is positive, or I can take f of x is equal to e raised to x, which is very known function actually. So what is the value of e? So value of e lies between 2 and 3. Okay, so f of x is equal to e raised to x. So these kind of functions are called as exponential functions, because in that functions x is in the exponent, right? After these exponential functions, the last type of functions is a logarithmic function. In the logarithmic functions, we find a log of that value. Means it is defined like this: f of x is equal to natural log of x, log of x to the base e. Such a log is called as a natural log. So f of x is equal to log of x to the base e. Such a function is called as a logarithmic function. Now in our course, we are not finding out the values of logarithmic functions or something more detailed. We are just trying to find out what type of functions are there, and we should be able to classify the functions if they are given to us. Means suppose you are given some functions, then you should be able to tell which of these functions is constant, which of the functions is a linear function, which of the function is a power function, which of the function is exponential function, which of the function is logarithmic function. So you should be able to tell all these things by just looking at that function. So that is the main idea behind this particular classification. Now after discussing the various types of functions, let us just move to some of the examples based on these particular ideas. So the very first question is like this: find the value of a function f of x equal to x square plus 1 at x equal to 2. Find the value of function f of x equal to x square plus 1 at x equal to 2. So how to find a value of function at that point? So if you want to find the value of function at that point, you just have to do one thing. You have to put x equal to 2 wherever there is x in that function. So here you can see that it is x square plus 1. So x is here, right? So just put the value of x equal to 2 in that place and you will get the value of function at that point. Okay, so the answer will be something like this. Then what is f of 2? So f of 2 is going to be x square means 2 square plus 1. So answer will be 5. So the value of function at x equal to 2 is 5. If I will ask the same question with different set of function at point, suppose I am taking f of x equal to 2 raised to x and I want to find the value of function at x equal to 4. So what is the value? So now here this function is exponential function 2 raised to x, right? You have to just find out the value of function at that point. So you have to do one thing, just put x equal to 2 wherever there is x you are looking, wherever there is x you have to just put x equal to 2. In this case also you need to find the value of function f of x equal to 2 raised to x at equal to 2. So you have to just put 2 at the place of x. So f of 2 is equal to 2 raised to 2. So that is just 4, right? So similarly you can go for the finding the values of functions of some other functions as well. Let me take some more example. Fine. Now suppose I am taking a function f of x equal to x square plus 3 raised to x and I want to find out the value of function at x equal to 3. So what is the answer? So just you have to put x equal to 3. So f of 3 will be equal to 3 square plus 3 raised to 3 because इथे x होता, so x च्या जागी 3 पुट केला, so 3 चा स्क्वेअर प्लस 3 raised to 3 कारण इथे x आहे, so 3 raised to 6 आन्सर येणार 9 प्लस 3 चा क्यूब आहे 27, so 9 plus 27 is 36. So answer will be 36. So in this way you can find the value of function at given point. After discussion of these functions in detail, now I can go and start some interesting and important functions in our syllabus. The very first function that is very interesting and very important too is the demand function, right? Now let us talk about this. What is demand function? So the function between price and demand. Okay, so what is the relation between price and demand? First of all, so if price decreases, suppose in a market, suppose a price of certain thing decreases, then what will happen with the demand? Whether demand will increase or demand will decrease. So it's very simple. If the price of the certain thing is less, then demand will be high. Okay, so if price decreases, then demand increases. And if price increases, if something is very expensive, costly, then nobody is going to buy that easily. So if price increases, then demand decreases. Okay, so this is a relation between price and demand. Okay, so how can we plot this relation in a graph? So suppose this is my graph, this is a price, suppose I am writing price on the x-axis, and suppose I am writing demand on the y-axis. So I know that when price is low, demand is high, and when price increases, demand decreases. Okay, so demand decreases. So what happens? So for lesser price, higher will be the demand, and then demand will go on decreasing. So curve will be of this type, right? So this type of curve you will get for this particular function. Okay, so this is called as a demand curve. So this curve is called as a demand curve. Okay, now similar kind of discussion can be done for the supply function. Okay, now let's talk about the supply function. Before that, let me tell you what is the notation for demand function. So here, when actually we are taking a price and then we are finding the demand, right? So suppose P is the price, right? And suppose capital D is the demand, then demand is a function of price. Okay, because first of all we are taking what is price, and at this price we are finding out what is the demand. Okay, so whenever we will put price, we will get the demand. So the demand is a function of price, or equivalently we can say that price is also a function of demand, but right now we are just talking about the demand as a function of price. So d is equal to f of p, it is the notation. Sometimes demand is denoted by q also, so you will find that in some examples q is equal to f of p will be your demand function. So q is the demand and p is the price, and f is the rule function. Now let us talk about the supply function. So before talking about supply function, I would like to write down the relation between the price and supply. Okay, so as price decreases, what will happen with supply? Now if the price is low in the market, supply will be not interested to supply that particular thing in a higher amount. So as price decreases, supply also decreases, right? And as price increases, suppose price is higher, price of certain thing goes on increasing, then supply will also be higher, so supply increases. So there is direct relation between supply and price. Means if price is low, supply is low. If price is high, supply is high. So if I will plot a graph of this, then let me again take the same things. Price on the x-axis denoted by P, supply on the y-axis denoted by capital S. Okay, then lower the price, lower the supply, higher the price, higher the supply. Okay, so the supply curve will be like this. Okay, you may take it as like this. This is your supply curve. Okay, lower the price, lower the supply, higher the price, higher the supply, and this curve is called as a supply curve. Okay, and now you can see that supply is a function of price, because first of all we see what is the price and then we'll find out what is the supply. So supply, that is S, is a function of price, so I can write it as G of P. G is a function, P is price, and S is a supply. Okay, sometimes supply is also denoted by Q, so Q is equal to G of P. That is also the notation for writing down the supply. Now this is all about the supply, demand function and supply function. After talking about demand function and supply function, let us now try to see, as per the market, what will be the scenario. Basically there is always imbalance between the market, right? Means if the demand is high, okay, then supply is low, and if supply is high, demand is low. Okay, or this kind of things happens in market. Okay, means what I am telling, suppose price is low. If price is low, then demand will be high, but supply will be low. And if price is high price is there, the demand will be low but supply will be high. So this kind of imbalance always occurs in a market. So under what condition we can say that there is a balance in the market? So ideal situation in the market where balance can occur is called as a demand equal to supply. It can happen only when the demand is equal to supply, and that point at which this particular thing happens is called as the equilibrium point. Okay, so let me just talk about this now. So I'm going to talk about the break even point, which is also called as a equilibrium point. Break even point, BEP, it is also called as a equilibrium point. Means at that particular point, what happens? Supply in the market is equal to demand in the market, so equilibrium point. Let me just explain that idea by using a graph. So this is your graph, right? Fine, this is your price on the x-axis, and let us take demand as well as supply and let's try to combine both the curves in one diagram. So suppose demand oblique supply we are taking here. So the first thing, let me just take one color. Fine, so first of all let me draw the demand curve. Price is low, demand is high, price is high, demand is low. So this is your demand curve, right? So this is demand curve in green color, right? Demand curve, and you know how the supply curve is. So let me take blue color, and this is your supply curve. Price low, supply low, price high, supply high. So this is supply curve. in a blue color, right? Now you can see that there is a point of intersection. These two particular curves intersect each other at this point. This is a point of intersection, right? At this point, what happens? If I will try to see the situation at this point, I can easily see that at this point demand and supply both are equal. Okay, at this point demand and supply both are equal, so it is called as a break-even point. Okay, this is called as a break-even point. This is BEP, break-even point, equilibrium point we can say. And at which price this thing has occurred? So we can see here that if I will try to find out the price, I will just plot a perpendicular line from that. So this is the point at which at this price this equilibrium has occurred, right? So I can tell that this is the equilibrium price, means a price at which equilibrium occurs in the market is called as a equilibrium price. Okay, so let me repeat my ideas. So price is taken on the x-axis, demand oblique supply is taken on y-axis. So I have plotted both the curves in one diagram. The green curve is nothing but demand curve and blue curve is nothing but the supply curve. Both the curves intersect each other at one point. At that point, if I will find out, I will get that demand, that is capital D, is equal to supply. D is equal to S. So this is called as a break-even point, and the price at which this happens is called as an equilibrium price. Okay, so I will now take some examples and I will show you how can we find these break-even points and equilibrium prices. Okay, so let me just take one example of this particular thing. Here I have taken two examples for the discussion. Okay, the first example is that demand and supply curves are given to you and we have to find out the equilibrium price and corresponding quantity, right? Okay, anyways, no problem. Now we will try to solve the first question. If the demand and supply curves of a commodity are given by this respectively, so let me write, this is demand, right? So demand curve will be written in a highlighted in a yellow color, right? And then supply curve will be highlighted in a green color, say. So this is supply curve, so this is supply curve, right? Fine. Now just what we have to find out, we have to find out the equilibrium point. So let me write down the solution. Just see how do we find out the solution. So solution of A, I know that at break-even point, what will happen at the break-even point? So at break-even point, demand is equal to supply, right? So therefore, what is my demand? Demand is highlighted in a yellow color. So demand is 9 plus 2p minus 3p square is equal to supply. Supply is p square plus 2p minus 7. So this situation will happen at the break-even point. Now I have to find out, or I have to rather solve this particular thing for the price. So what I will do, I will shift these terms from the left side to right side. So I will get 0 on the left side, okay, and all the terms will be shifted to right side. So 3p square, so let me write down the terms of right side first of all as it is, minus 7. So this minus 3p square on the left, when I will move this term on the right, it will be plus 3p square, right? Then 2p plus 2p, whenever I will move this plus 2p on the across the side, I will get minus 2p here on the right side, and 9 is plus, whenever I shift it, I will get minus 9, right? So in this way I will shift all the terms from the left to right. So therefore let me change the sides. So this is a p square plus 3p square, so it is 4 times p square, okay, 3p minus 2p, okay. Just a second, let me, I think I have taken, yeah, right. So you can see here I have taken here, it should be 2p, right? So 2p minus 2p, so it's 0. So 2p get cancels with each other, and minus 7 minus 9, so it's minus 16, and this is equal to 0. right? Okay, so 4p square minus 16 equal to 0 is the case now. So therefore 4p square is equal to 16, because I will shift this minus 16 on the right side, so it will be 16. So therefore p square will be equal to 16 divided by 4, that is 4. Okay, so I can see here that p square equal to 4. Then what is the value of p? P square equal to 4, that means value of p is equal to plus 2 or minus 2, कारण ह्या दोन्ही नंबरचा स्क्वेअर 4 येतो, बरोबर आहे. पण प्राइस निगेटिव्ह असू शकत नाही, सो दॅट्स वाय वी discard this particular number and we just take 2. So that's why I got p equal to 2. Okay, so p equal to 2, this is nothing but my equilibrium price. So this is the price at which the equilibrium occurs. So p is equal to 2 is the equilibrium price. Okay, let me write it here for your understanding that this is my equilibrium price. Okay, equilibrium price. Now I want to find out the break even point, or rather I want to find out the equilibrium point. But for that I know the price. I know that demand and supply will be equal at this price. So either you find demand or you find supply, depends on you. So supply at, let me find the supply at p equal to 2. What will be the supply at p equal to 2? So I know the supply curve is highlighted in a green color. So supply curve is p square plus 2p minus 7. So at p equal to 2, it will be equal to p square plus 2p minus 7. So that is equal to p square means 2 square plus 2 times p means 2 into 2 means 4 minus 7. So it's going to be 8 minus 7. Okay, so that is equal to 1. So that means supply is 1 unit. Okay, and demand will be also 1 unit because supply is equal to demand, right? So at p equal to 2, supply and demand are equal, so that's not going to cause any problem, and that's 1 unit. So what is the break even point? So break even point will be given like BEP. Break even point is, price will be written as first because it is on the x-axis, so price will be written first, 2, and demand or supply, right, because both are equal, so that is 1. So this is your break even point, right? Now there is another example, and I will give it to you as a homework, but I will tell you what will be the answer at least. Okay, so again you have to go in this way, that demand and supply are equal. So 5 minus 2p is your demand, that will be equal to supply, that is p square plus 2, right? So therefore you will get, if I will shift this, then p square plus 2p minus 5, that is minus 3 equal to 0. And you have to solve this by using the roots. You have to find the roots of this by using quadratic equation. You have to find two numbers whose product is minus 3 and addition is 2, so 3 and minus 1. Okay, so 3 and minus 1 means there is p minus 3 and p plus 1 equal to 0. So that gives me p equal to 3 and p equal to minus 1. P is not negative, so p equal to 3 is the answer. Now how do I find out this? Actually I have applied the little mathematics from which is we have already seen in the previous classes to find out the roots. That I want to find two numbers. असं मला दोन नंबर फाइंड करायचे की ज्यांचं मल्टिप्लिकेशन -3 येईल आणि ॲडिशन 2 येईल, असे मला दोन नंबर्स फाइंड करायचे. सो असे दोन नंबर मला मिळतात 3 आणि -1. कारण 3 आणि -1चा प्रोडक्ट केला तर तो येतो -3 आणि ॲडिशन केली तर इथे 2, म्हणजे हे दोन नंबर्स आहेत. मग 3 हा नंबर असेल तर मग तुम्ही लिहिताना p-3 लिहायचं, आणि -1 हा नंबर असेल तर लिहिताना +1 लिहायचं इक्वल टू 0. म्हणजे याच्यावरून तुम्हाला किंवा तुम्ही हे जरी नाही लिहिलं, म्हणजे तुम्हाला हे नाही लक्षात आलं तर हे इग्नोर करू शकता तुम्ही हे सगळं. यू कॅन जस्ट फाइंड टू नंबर्स 3 आणि -1. सो पीच्या दोन व्हॅल्यू तुम्हाला मिळाल्या. पीची पहिली व्हॅल्यू मिळाली 3, दुसरी व्हॅल्यू तुम्हाला मिळाली -1. पी निगेटिव्ह असू शकत नाही, त्याच्यामुळे पीची व्हॅल्यू 3 घेणार आपण, राईट. सो हे सॉल्व करा आणि याचे करस्पॉन्डिंग क्वांटिटी लिहून ब्रेक इव्हन पॉईंट काय येईल ते फाइंड आउट करा. सो आजच्या लेक्चरमध्ये आपण काय काय पाहिलं आहे? सो वी हॅव सीन द कॉन्स्टंट्स, व्हेरिएबल्स, देन फंक्शन्स, फंक्शनचा डोमेन, कोडोमेन, फंक्शनची रेंज, त्याच्यानंतर टाईप्स ऑफ फंक्शन्स, फंक्शनचे टाईप सगळे बघितले 1 by 1. 5 प्रकारचे फंक्शन्स आहेत. त्याच्यानंतर हाऊ टू फाइंड द व्हॅल्यू ऑफ फंक्शन ॲट अ पॉईंट. देन वी सॉ अबाउट डिमांड फंक्शन, सप्लाय फंक्शन, त्यांचे कर्व्स कसे असतात, दोन कर्व ज्या पॉईंटला इंटरसेक्ट करतात दॅट इज ब्रेक इव्हन पॉईंट. करस्पॉन्डिंग प्राइस इज कॉल्ड एज इक्विलिब्रियम प्राइस. आणि त्याच्यावरचे आपण 2 एक्झाम्पल सॉल्व केलेले आहेत. सेकंड एक्झाम्पल इज ऑब्वियसली होमवर्क फॉर यू, बट आय हॅव गिवन इज अ हिंट. ओके. सो विथ दिस आय स्टॉप हिअर. I hope you must have understood all the contents that I have taught in this lecture. Okay, so with this I stop here. Thank you.